In this lesson, we will be discussing the functional groups. In organic chemistry, most of the compounds are hydrocarbons, mainly made of carbon and hydrogen alone. Carbon has the property of catenation because of its 4 valence electrons, and this gives rise to the many compounds that you find in organic chemistry. Carbon has the ability to form long chains, and it has the ability to combine with other elements like oxygen, halogens, sulfur, etc. So the functional groups are atoms of different elements which are attached to carbon atoms, and it will give specific properties to the carbon chains. The functional groups need not be attached at the end of the carbon atom. It can be anywhere in the chain. So let's take the functional groups found generally in organic chemistry one by one. Let's take the alkenes first. The functional group present in alkenes, a homologous series, is a carbon-carbon double bond. So whichever compound you take of alkenes, you will find a carbon-carbon double bond, and all the chemical properties in this family of alkenes is because of the carbon-carbon double bonds. The next functional group is the halogenoalkanes. Here there is the presence of the single bond, and there is one halogen present as a functional group. This halogen, we can take it as X, and the rest of the molecule we can take it as R. So the general formula can be written as Rx, where R is the alkyl group and X is the halogen. The halogen can be chloride, chlorine, bromine or iodine. So any of the halogen which is attached to the carbon will give rise to the halogenoalkanes. The next functional group that we come across is the alcohols. The characteristic properties of the alcohol is the alkyl group attached to an OH. So here you have the first member of the alcohol family or alcohol homologous series, and it is ethanol. CnH2n plus 1 OH is the general formula of alcohols, and the OH is the functional group that we'll find in the alcohol family. Then we have the next family, that is the carbonyl group, C double bond O. Now if the carbonyl group is attached to a carbon atom and a hydrogen atom, then we call them as aldehydes. If you have only a carbonyl group which is attached to 2 methyl group, then this becomes the ketones. So aldehydes is CH double bond O and an alkyl group. So RCH double bond O will form the aldehydes, and for ketones you will have R C double bond O and R dash. So R and R dash will signify the alkyl groups, which can be a methyl group, an ethyl group or any other alkyl groups. But the presence of a C double bond O or a carbonyl functional group in the molecule will give rise to the ketones family. The next is the acids found in organic chemistry, also known as carboxylic acids. They have the functional group C double bond O, OH. And if this functional group is attached to an alkyl group, we have the general formula RC double bond O, OH, and this is the carboxylic acids that you find in organic chemistry. They are weak acids, but they are very essential in all and is found in all living organisms. The last functional group under discussion is ether. There you will find that a carbon is attached to oxygen and then to another carbon. So COC bond is the functional group in ether. So you should be able to identify the compound looking at the functional group and the alkyl group that is present in organic compounds.